Hello, this is Ms. DB. In this video we are going to multiply special products and then we're going to factor special products. So we'll do one and then we'll undo it. So the first part we're going to do is find the square of a binomial. That means that you have a binomial, two terms, and you're multiplying it by itself. So x plus 4 squared is the same exact thing as x plus 4 times x plus 4. You don't have to use any special rule for this. You can just multiply them, write them out twice, and then FOIL. And you get x squared plus 8x plus 16. However, for some reason, people look at x plus 4 squared and think it should be x squared plus 16. They just square the first term and the last term, and they forget all about the middle term. And if you do that, you'll get the wrong answer every time if you miss the middle term. So there is a formula, a rule, that can help you remember that there's a middle term. If it's a plus b squared, then your answer will be a squared plus 2 times a times b. So in this example, a is 1 and b is 4. So in this example, when you multiply them, you get 4. A times 1 times 4 is 4. And if you multiply that by 2, you get 8. So you can see that that would give you the middle term then. And then which was 8x. And then the last term is the 4 times 4. Oh, I forgot the x here, sorry. A times 1 is, a is x. So 4x times 2. There, now it's 8x. All right, so now let's look at some more examples. This is where the common mistake is here. All right, so we have, let's look at number 2, because there's more going on there than just an x. It's a 3x and a minus 7. So the first option is just to write this twice, 3x minus 7, and it's squared, so that means 3x minus 7 times 3x minus 7. So we can just write it twice, and then we can FOIL it. 3x times 3x is 9x squared, because 3 times 3 is 9. Then we do the outer. 3x times negative 7 is negative 21x. And then the inner is negative 7 times 3x is also negative 21x. And then the last term times the last term is negative times negative is positive, so positive 49. And then we can combine our middle term and get 42x minus 42x plus 49. And that's our solution. Or we can use the formula. The formula says that you can take, if you have, let's see, this one is the a minus b format, because there's a minus sign in there, that will be equal to the first term squared minus 2 times the first term times the last term plus the last term squared. So in ours, a is 3x and b is 7 squared. Okay, so the first term, a, is 3x, and I have to square that. And then we'd have 2 times the first term, 3x, times the last term, 7, and then plus the last term squared. So 3x squared is 9x squared, because it's 3x. Both of those things have to be squared. So 3 squared is 9, x squared is x squared, minus 2 times 3x is minus 6x, times 7. I missed the 7 there. Let me fix that. So it's 2 times 3 times 7, so that's minus 42x. And then plus the 7 squared is plus 49. These should be equivalent. They are. So either method will work. Use whichever one you prefer. Number 7 is not written as a squared binomial, but it could be. Because 2x plus 5 and 5 plus 2x, you could use the commutative property to rewrite the second set of parentheses as 2x plus 5, which then could be written as 2x plus 5 squared. Now, if you're going to use the FOIL method, then you might as well just leave it as it is. If you're going to use the formula, then this would be your terms for the A and the B. All right, we also have this kind of special case. If you have a binomial times a binomial, and they're exactly the same, except one is a plus and one is a minus, something interesting happens to the middle term. So let's look at x plus 4 times x minus 4. First times first is x squared. The outer would be minus 4x because you have x times negative 4. The inner would be plus 4x. And then last times last would be minus 16. So when you go to combine your like terms, the middle term cancels. Negative 4x plus 4x is 0. So you're left with x squared minus 16, no middle term. And that's what will always happen. It follows that same pattern whenever you have two binomials being multiplied that are exactly the same for A and B, except one of them will have a plus and one will have a minus. And it does not matter if the first one has the minus and the second one has the plus. This will work each time. But one has to be a plus, one has to be a minus. The first term and the last term have to be exactly the same. Now you can also use FOIL to get these problems. You don't have to use a special formula. For example, in number 9, I could do FOIL. First term times first term would be 4x squared. The last term would be 2x times 1, that's plus 2x. The inner would be minus 1 times 2x, that's minus 2x. And then the last times last would be minus 1 times 1 is minus 1. So 4x squared, 0 is my middle term. So I don't need to write it. 2x minus 2x is 0. This would be my answer. Or you can use the formula, which might get you there a little bit quicker. Note that in the formula, the answer will always have a minus sign. Always. And you can practice doing these problems either with FOIL or using the formula. Be careful that when you square something like number 14, if I'm going to use the formula for this, first I make sure that I can use the formula. Okay, A is 2q cubed. Wow. And this is also 2q cubed. And B is r squared, and B is r squared. One's got a plus, one's got a minus. I can use the formula. The formula says, here's the formula, that I can just write this as a squared minus b squared. A is 2q cubed, and it's minus, always minus. And B is r squared, squared. I have to square both of them. I'm not done. This is not simplified. This is crazy looking. So when I square 2q to the third power, I have to square the 2, and I have to square the q cubed. And the other one is a little easier. This is just r squared to the second power. I wrote the same thing twice. So 2 squared is 4. Q to the third power raised to the second power. The rule is when you raise a power to a power, you multiply the exponents. So it's 4q to the 6th minus r to the 4th, because I have to multiply 2 times 2, and I get my answer for number 14. All right, now we're going to factor. So we're going to take one of these kind of expressions, like this, or like these, and we're going to go backwards and try to write it as what we had to get to there as its factors. All right, so we're going to start with the perfect square trinomials. So these are, if you have a trinomial, a squared plus 2ab plus b squared, so that it is, the middle term is 2 times a times b. That's the tricky part to check. And the first term is something squared, and the last term is a perfect square. Then we can use this formula to factor it more quickly. Let's look at an example. Okay, x squared plus 8x plus 16. You can factor this one of the other ways that we have learned, or you can say, hey, look, this is a perfect square because x times x equals x squared. This is a perfect square because 4 times 4 is equal to 16, and 2 times 4 times x equals my middle term. So the middle term is the trickier one. It's what is the square root of this times the square root of this times 2 has to equal that. If you can see that, oh yeah, this is a perfect square trinomial, then you can use the formula to quickly factor this. And the way we would quickly factor it is we would say, okay, I would probably put, yeah, I'll just go ahead and do it this way. Yeah, I'd probably do this. I'd probably do this first and then write it as a squared. So I'd say, oh, look, I can do the x times x, that's the square root of x squared, my first term. And the b is the square root of 16, so I would do 4 and 4. And these are all pluses, so I would put pluses here. And then I would probably FOIL this to check x squared for the first. 4x plus 4x is 8x, good. And then the last times last is 16. And then if you see that, oh, that's x plus 4 times x plus 4, I can write this as x plus 4 squared. You don't have to. This is correct, this is correct. Either are correct. So this formula is a way for you to recognize how to factor some kinds of quadratics. If you don't notice that this was a perfect square trinomial and you just factored it one of our other ways, then that's completely fine. But sometimes it helps you factor things that are otherwise kind of a lot of work. For example, number 23. Number 23 has a number in front of it. Those are more work. But I might say to myself, well, okay, it's 25. That's a perfect square. Hey, 36 is also a perfect square. The square root of 25x squared would be 5x. The square root of 36 is 6. If I multiplied these by 2, do I get the middle term? If I do, this will be easier to factor than going through all the steps. So 2 times 5 is 10, times 6 is 60, and I need an x. That is the middle term. That means that I can use the formula to factor this a little bit faster. So the formula says, let's go back. The formula is right here. It's pluses, so it's this one. If I have this, which I already know I do, then I can write a plus b times a plus b, or I can just write a plus b squared. My a was 5x, that's my a, and my b was 6, that's my b. So I can write this faster as, I'm going to type it, as 5x plus 6 times 5x plus 6. And you can FOIL it back to check. Or, since those are both the exact same thing, I could write this as 5x plus 6 squared. Squared, you can use this to show that it's squared, or you can go ahead and do the formatting to put the exponent on it. And that's it. So that if you see that it's a perfect square trinomial, you'll save yourself some time on the more complicated ones. Number 25, I'm just going to start you out here with what is A and what is B and C and so on. So I could write this as x squared squared. That's the same exact thing as x to the 4th. I could write 121 as 11 squared. And we need to check, is 2 times the square root of the first term, which is a, which is x squared, is that times b, which is 11, is that equal to our middle term of 22x squared? So 2 times 11 is 22, and then it's an x squared. It is. So that means I could rewrite this as a, this is my a, plus b, this is my b, times a plus b. Or you can write it as a plus b squared. So sometimes a and b are more complicated than just, a single number or a variable. So I didn't do 25, I just made sure it would work, and it will. One more thing to look at And that is sometimes when you're doing a quadratic, it's not a trinomial. There's no middle term in this example. It's 9x squared minus 4. It's still a quadratic because we have an x squared term. It's not a trinomial. So you might go, I don't know how to factor this. You can factor it by our other methods if you add a middle term in, and your middle term would be 0 or 0x. So in 26, I could factor this the same way we factored our other problems if I remember that there is really a middle term, it's just 0. And then I could say, okay, what are the factors of -4 that would add up to 0? What are the factors of -4 that would add up to 0? Well, -4 times 1 is not going to work. What about -2 times +2? I add -2 and +2 together, I get 0. So that's the factors that are going to work. So I can factor this as x minus 2 times x plus 2. And then I can FOIL and check, and it's going to work. This is not the same as x minus 2 squared or x plus 2 squared, because it's not exactly the same sign. So you would leave your answer as x minus 2 times x plus 2. The formula says that you can do this without having to like figure out what factors add up to this or add up to that. If you have a perfect square minus a perfect square, then you can write it as the factor of the square root of 1 plus the square root of the other one times the square root of 1 minus the square root of the other one. All right, so the first thing to do is make sure that you have a perfect square minus a perfect square. We don't have that in 28. 4 is a perfect square, but 400 is not. Oh, 400 is a perfect square. 20 times 20. I was going to say we could factor out a 4 first, and we could, but 20 times 20 is equal to 400. So the square root of 400 is 20. So there's two ways to do 28. We could start by factoring out the greatest common factor, which is 4. And then we could say this is x squared minus 100. And then we have a perfect square minus a perfect square. So when you have a perfect square minus a perfect square, you can use this formula that says you can take x minus 10, and in the second parentheses, x plus 10. That's method 1. Method 2 is we could just right away say we have a perfect squared, and 4x squared, the square root of that would be 2x. And the square root of 400, we just checked, and it was 20. And then in the other set of parentheses, it would be 2x plus 20. One has to be a minus, one has to be a plus. Both of those are correct. I'm going to highlight this. These would both be answers. However, this one down here does not have it, the greatest common factors could still be factored out of it. So really, the better answer would be the 4 times x minus 10, x plus 10. You really should factor any common factors out before doing this. So in something like 32, this is not written correctly yet. It's supposed to be something minus something. So I'm going to rewrite this as 25 minus 36x squared. So when you write this in its parentheses, it's going to look a little different because the square root of 25 is 5. There's no x on that first term. And it's the second term that would have the x. And then it would be 5 minus. It doesn't matter if your first set of parentheses has the plus or the minus, as long as you do one of each. And then, of course, you can always FOIL this back to check. We would have first term times first term is 25. The outer would be 5 times -6 is minus 30x. The inner would be a plus 30x. That's good because I want this to equal 0 when I add them together. And when I combine my like terms, the middle two terms would cancel each other out. There's a 0, so I would just have 25 minus 36x squared, which is what not quite what I started with because I rewrote it so that the that it would be a minus b instead of negative a plus b, which would be harder to use the formula for. So practice these, and remember that these are shortcuts. They are not something that you have to recognize. You can use other methods of factoring and of multiplying and still get the correct answer. Thank you very much and have a wonderful day.